Okay, thank you for the kind introduction and thank you for the invitation. And let me see. Okay, so yeah, I can skip this one. So yes, I'm affiliated with that university. It's the 12th oldest university in the world. In fact, it is said that the uniforms for the Harry Potter books were inspired by the uniform, the official uniform from Coimbra, because J.K. Rowling was in Portugal, living in Portugal for some years. So we were told that the inspiration comes from there. I don't know because I tried to fly a broom once, it doesn't work. Okay, but anyway. So yeah, if you eventually after the talk, if you want to ask me something, please feel free to use my email address. Okay, and I'm always willing to know new people, work in new problems. So that's it. And so today's talk, well, it's about building automation systems, so how you can use building automation to steal information, and this is more or less the outline that I'm going to follow. And I'm going to start, usually I like to do this, I start from really the beginning, and it has to do with the problem of protecting data. It's always the old trade-off, okay? When I was in the industry, I was taught that I should never go to my boss and say, we need to invest in security because, no, first I need to scare him. I need to tell him this is what is going to happen if we have a breach or if we lose the systems or if something bad happens. So it was easier to get the money, the budget, if I scared my boss first. So this is an old problem, okay? And in the end, it comes to this. Companies, organizations, even people need to understand how much it costs to protect something when compared how much it costs to lose it. And in the intelligence community or the security community, you have lots of standards and recommendations to deal with this. The Department of Homeland Security, for instance, have a directive that specifies the something that is called the secure compartmented information facilities. And you have similar things all over the industry in Europe and United States and so on. And and yes, so but curiously, if you look at those standards that define the so-called secure facilities, one thing they have in common is they try to air gap physical spaces at any cost. Okay, so the idea is, for instance, if you look at the specifications for the SCIFs, they go to the SCIFs are used by the intelligence community mainly. They try to create Faraday cages. Okay, so the idea is that if you have a SIF compartment, they even try to enclose it within a Faraday cage, and they try to disconnect. So no wireless, no network connectivity there. So it's really a secure facility. And the main principle here that they follow is basically this: cut from the external world, air gap things. And you have lots of recommendations about this. Okay, you even have acronyms for that. It's the SAPS. Department of Defense likes this one. The SIF is for the intelligence community, but in Europe you will find this. For instance, if you work with the airspace industry, for certain projects, certain external contractors are mandated to have this sort of facility. Okay, for instance, there is a company in Portugal called Critical Software that works with, among other partners, Westland Helicopters, and they also have one of these facilities where they have a computer there. Everything is disconnected, and if I need to basically query and consult the plans for something, okay, I need to have clearance to access that compartment, and I can only check that information within that compartment that is isolated. It's like some sort of a vault within the headquarters of the company. And this is the main principle that they follow. Okay, so isolate and isolation, it seems, or at least it's widely accepted in this community, that is a good thing. But we all know that air gapping is not completely foolproof. And you know what happened in the past. If you look at the lessons that, and history is very good at teaching this sort of thing, Stuxnet, Nathan's facility was somehow air gapped from the rest of the infrastructures. It was disconnected from networks and so on. And even though the strategy that they used to propagate Stuxnet was very clever, was a trick, a strategy of patience. So they have also contractors, okay? People who work with automation, PLCs, centrifuges, and so on. So the trick was that, okay, we cannot go through the front door, so we are going to indirectly attack the external contractors and wait until someone goes to perform a maintenance operation, and brings an infected USB pen with him, and that's it. So the way Stuxnet reached Natanz was basically a game of patience, but it worked. And in the end, well, they were air-gapped, but someone managed to overcome that. So and there you have lots of other interesting tricks. There is a team led by Dr. Mordecai Guri from the University of Ben Gurion in Negev in Israel. They have published lots of papers about the strangest tricks in the book for data exfiltration. So you have data exfiltration with keyboard LEDs, you have data exfiltration with the LEDs of the Ethernet network, the network card, you have exfiltration by electromagnetic radiation leaks from cables, from CPUs. Not all tricks are equally feasible. If you look at the distances, let's face it, for instance, CPU electromagnetic radiation leaks, it's basically you need to have the receiving end like next to the target. So it's not that feasible. It's a proof of concept, I would say. But for other strategies, they have some very interesting demonstrations. They have one that they have a drone with a camera with the digital stabilizer, and the drone is basically filming a computer that is inside the room, and they are just getting the sequence of the keyboard LEDs, and they are filming because they manage to modulate information on that, and then what they do is to process the video stream and demodulate the information. So they have all these sorts of very nice tricks. So in the end, yeah, air gap it might be a good idea, but as part of a broader approach. And you shouldn't rely only on air gap, because in the end you have people and also lots of creativity to overcome this sort of thing. And this takes us to the main topic of this talk that has to do with abusing. And by the way, the acronym means building automation and control systems. Okay. And this is quite an interesting vector. Basically, nobody cares about security and BACS security specifically when it comes to this sort of thing. But they are vital. When we talk about intelligent buildings, smart buildings, and we talk about energy efficiency and so on, one of the cornerstones to achieve this is, well, building automation. Okay, you need it. And the question is that this means that quite often you have a parallel communication infrastructure of some sort that is independent of the IT network that just connects devices on some sort of bus. Okay, and this kind of mechanism is like capillary to some buildings. It's intertwined with the entire infrastructure of the building is connected to lighting, air conditioning, well, all sorts of things that have to do with comfort and so on. So, and unfortunately, that special word automation already hints at a big problem, because if you are familiar with what happened in the past, the automation domain, and specifically SCADA systems and distributed control systems, don't get me wrong, they are very good at what they do. Okay, hardware that is designed for these purposes, it's really designed to run 24/7 without any sort of maintenance for years in a row, without sometimes even beyond the end of life of the device. It's quite common to find, for instance, PLCs, automatas, that the manufacturer doesn't even exist anymore, but they are still running, and nobody knows what the thing is running. In some cases, they don't even know what the automata is doing. In my department, we had one. Basically, we have a lightning system that supposedly is intelligent. And some years ago, they realized that we need to reprogram that, but nobody knew how the system worked. In the end, after some trial and error, we discovered a PLC in the basement of the building that was there with an old PC, a 486. It was the engineering station that was left by the integrator, and that thing was running and managed for like 25 years. Nobody knew that it was there. So don't get me wrong. We are talking about things that really work. It's just that security was not a concern. It was not a problem. And their gapping for them was enough. But what happened is that lots of these equipments, actually, if you go to Shodan, you'll discover that if you search for protocols that are more or less generic when it comes to automation, like Modbus. And Modbus is something from the 70s of the past century that you might say, oh, but we already have a replacement for Modbus. Check the catalogs of the main manufacturers and tell me how many devices don't support Modbus. Okay, and it's old style Modbus, so it's plain text, no encryption, no authentication, no nothing. Okay, it's the majority of the devices, unfortunately. And if you look, and for instance, you search for oh, I cannot. Let me see what's happening. Oh, so if you search, for instance, for Modbus devices, and I selected a country, France, you'll find, well, stuff directly exposed on the internet. And I did some work, some homework, and I specifically found this target here, okay? And of course, OSINT is your friend. In this case, it was really Google. And I tried to find out what this thing was, and this was a building automation controller. Okay, this one is usually applied to HVAC, so heating, ventilation, air conditioning control. And this thing was completely exposed on the internet. And yeah, it uses Modbus and several other protocols but it's very easy to go to the front door, pick it, and play with this. And this thing is connected to the, I would say, the nervous system of a building. So this sort of thing is completely exposed on the internet. So this is an old problem that you probably are already familiar with it. The problems from automation also exist in building automation. So the old issues that we are still fighting in SCADA, they also exist in BACS. And the same scenes, black boxes, air gapping, relying on sometimes features that are not documented. So the idea is that some people still believe I don't document it, so it's inherently secure. It's not. It's just a challenge. It's like an invitation for someone to do something about it. And once you connect these things to other networks and IT networks for management purposes, for engineering and maintenance purposes, debugging purposes, well, you are just opening Pandora's box. And well, you have similar to, I would say, normal automation. You also have protocols and technologies that are specific of BACS. And one of them is KNX. This thing is more or less 30 years old. And KNX, it's one of the most popular buses used in building automation. And it's I have to admit, this thing is popular because it works. Okay, KNX is basically maintained by a consortium. It's a KNX association. You need to pay to have access to the tools, the standard, and so on. Regardless of the manufacturer of the equipment that you use, you have a tool that is provided by the KNX Association that is called the Engineering Tool Software, this ETS tool. So if you want to imagine, configure and prepare an ETS KNX environment, you pay, you get the ETS tool. You don't only get the ETS tool, you get the standards, all that stuff, okay? But you get the ETS tool and you use it to provision and configure the entire KNX infrastructure. And it's very simple. So you have several types of physical medium for KNX. One of them, the most common, by the way, is twisted pair. It's a twisted pair bus, 24 volt, 21 to 30 volt. It's quite tolerant, okay? And it's a shared bus. And this is, I have to say, it's quite clever. It works quite well. So, for instance, I can have a rocker switch from one manufacturer. That thing has an object, okay? And I can configure the object to, if I press the switch, the object, some attribute will change value. And there is a flag that says if that value is associated to a command being sent to another device. It might be a light fixture. And this thing works, I would say, quite well. If you look in terms of the vertical stack, in terms of automation, KNX is here. So it's mainly concerned with the physical layer, sensors and actuators, and then secondary in primary automation. It's not concerned with wide scope monitoring and nothing like that. You have other things for that, BACnet, for instance. But KNX, it's quite nice. And then you have KNX supports twisted pair, power line communications, Wi-Fi, and you have KNX over IP. KNX over IP is not that common, to be fair. You often see it in places where basically you connect the KNX network to an IP network for maintenance and engineering purposes. For instance, I need to manage, reconfigure parts of the infrastructure. So I have a KNX gateway that is connected to the, I would say, an IT network, conventional Ethernet network, and I have KNX over IP. Okay, and that's what I'm going to use with the ATS tool to configure all the devices. But the most common form of KNX that you will find in the wild, it's twisted pair. Okay, because it works, low bit error rate, quite reliable. It's the oldest form of the physical medium that we will find. So it's retro-compatible with all the changes and variations that you had in KNX, and it's really quite reliable. And in terms of topology and arrangement, it's very simple. This reminds you of old school 10 base 2 or 10 base 5 Ethernet. So the simplest structure that you have in KNX is a line. So you attach devices to a shared twisted pair bus that you call a line. And you can have up to 64 devices on a line. This has to do also with electrical load limitations. You have power supplies attached to the line because devices also receive the power supply from the KNX bus, okay? And then what happens? Basically, for a simple deployment, like an apartment, a line is enough. Okay? But if you are going for a multi-story building, what you might have is an area, and an area, what it is? Well, we have several lines, and then you have what is called the line couplers. That is that exactly like the old school repeaters and then the routers in Ethernet, these things basically offer some sort of isolation, very limited, between different lines. For instance, I can say that a device here can send a group message to a device here, but I need to configure the line coupler to route the message. Then the idea is that you can have eventually several lines for an area, but then if you need to connect areas together, and a good example might be a multi-story building, so each floor is an area, and you might have several lines. And then what happens is that you have the line couplers connected to each other, but also to the backbone coupler. The idea is that you can have, it's called area zero, by the way. It's also an area from an abstraction perspective. And the idea is that you can have all the areas connected together using a backbone line, and you use a backbone coupler for that. And it pretty much does the same as the line couplers do. Just a small remark. These things could offer some sort of security, but what happens most of the time is that if you want to implement whitelisting or blacklisting in these devices, they are very limited in terms of memory. So you don't have lots of resources to implement very elaborate whitelisting and blacklisting techniques. What you say is basically you say, I can forward this message and I can forward this message. You can have up to 15 areas connected to a backbone. So you see, this is a very simple arrangement. It's hierarchical. You are not supposed to create horizontal connections between lines. So this is an hierarchy. It's an acyclic graph, a directed acyclic graph, you might call it so, because in sense you are not supposed to create loops here. If you try to create a loop here, you will get into trouble for I think obvious reasons. And the framing by itself, it's equally simple. So this is a KNX frame. Addressing is quite interesting, by the way. You have two types of addresses in KNX, individual addresses and group addresses. Individual addresses are only used for one kind of task: debugging, configuration, setup of devices. Once you have all the installation working, communication between devices is achieved by means of group addresses. And this offers you the opportunity to implement point-to-point communications or point-to-multipoint communications. An example, I have a rocker switch. When I press it, I configure it to send a message to a group address. And that group address is subscribed by a series of light fixtures. So when I press the switch, it's not only one light fixture that will turn on, it's a group of them. So that's why it's useful to have this sort of thing. Each KNX device has what we call the group objects. It's very simple. It's memory areas where you have attributes. Some attributes can be together with flags that allow us to configure the device for certain behaviors. For instance, if I press the rocker switch, a Boolean will change state on. So, and I configure a flag that says, if this attribute changes, please send a group address, a group message to this group address. This is the way things work in KNX. And so even the protocols are simple. And what about security? First thing, I have to hand it to the KNX Association. They did a pretty good job recently. We have, since 2020, if I'm not mistaken, a variation of KNX that is called KNX Secure and KNX IP Secure. So they added encrypted authentication, and you have support for hybrid setups. This means that you have a device that supports KNX Secure, but on the same line, you have a legacy device. The ATS tool understands this and will configure the setup of the link between the groups to use, well, plain text KNX, because the two devices don't support encryption. Also, old school KNX has something that it's called the BCU key, the bus coupling unit key, that is extremely dangerous. Most integrators just don't use it. The idea of the BCU key is quite, I would say, correct. That is like this. You have a KNX project in the ATS tool. It's the integrator has a project for a building. It works like this. So, and the idea of the BCU key is that once you configure and set up the devices, you lock them using this key. And it's it's good for you not to forget it. Sometimes keys are stored together with the project, but this creates a problem. Most integrators don't use BCU keys for a very simple reason. If in the future someone needs to change something in infrastructure and doesn't have access to the original project, well, the devices are basically locked. They cannot do anything. So most of the integrators avoid setting the BCU keys. Quite recently, there was an attack in Australia where what they did in an hotel was to basically swipe the entire lines that they were in the areas, unload the devices, and set BCU keys, rendering the entire KNX infrastructure useless. They technically bricked all the devices. It took a company that what they did basically was to go to the hardware, and they had to do hardware.
Can I ask you something? Is this company Lim Security?
Yes.
Because we had a presentation, remember, from Thomas,
Yeah.
said us that he was a company that was doing that. He was explaining what actually happened. They didn't put any key.
Exactly.
He said that
yeah, it was them. It was them, Lam Security. Yeah. And so this is a problem because most integrators, they know that the right thing to do is to set the BCU key, but at the same time they think, if in the future someone needs to change something in this infrastructure, and I'm not in the business anymore, I don't know, something happens, and or the project is lost, well, you only can fix this by replacing device or having enough luck to have a company that just manages to remove the BCU keys, but it's not easy. With KNX Secure, it's nice, but you have a problem with this sort of thing. Basically, I would say that the huge majority of the KNX deployments out there are legacy. Most integrators, when they set up new deployments, they see encryption and authentication as a nuisance. There is a myth that it reduces speed and makes these things slow because this is a serial bus, 9,600 bits per second, by the way. And so I won't say that all of them, but I would say that some of them do this. They don't use encryption. It's an automatic setup in the ATS tool, but they go to the ATS dropdowns for IP and for the KNX devices, and they just disable security because they see this as a nuisance. So sometimes even for new deployments with new equipment, they just try to avoid this sort of thing because it can be difficult if you have to troubleshoot infrastructure and so on. So, and that you have also this collective misconception that is not true, that if you use encryption, things will become slow. It's not true, but several integrators believe this. And so now imagine this, and we discovered this situation. So you have a company, whatever, and you have a secure compartmented information facility. And we know at least about one case that it's really secure and compartmented, and they have all the thingies, but they also have a KNX line that is not isolated to the room. So you have a KNX line that runs across this area. So it means that you have a twisted pair line. It sounds crazy, but it happened. That connects the supposedly air-gapped room to something on the outside. So it's very easy, if you know a couple of things about hardware, to create a couple of KNX devices, and for instance, create a device that you can hide within, for instance, the light switch, the box, the chassis for the light switch. You can make it very small, and it feeds from the bus, so it's self-powered. You don't have to care about that. No batteries, no issues. It's just another KNX device that you are attaching to the bus, so you can hide it there, and then you can have a receiving device somewhere within the floor outside the secure compartmented room, and well, you can use this for the obvious purpose, that is to steal information. And um, and basically want to see if it was easy to create such a device. So of course, the devices that you find on the catalogs, nobody will sell you a device for this. Nobody does a device for this. Okay, you can buy switches and fixtures and all that sort of thing that you need for building automation, but of course you won't find it. So we built our own. It's called Alfred. This is our prototype. So what we have here is, it's not a complex thing, to be fair. What you have here is a microcontroller. Then it's attached to a twisted pair wart that also provides the transceiver for the twisted pair bus. And then you have an coupler for obvious reasons, because we need galvanic isolation between the KNX bus and the microcontroller. This is, well, we tried to make a good design and a robust design. It's not that it was mandatory, but this is the way to do it, okay? And then because it's not fast, so we can get away with an optocoupler and galvanic isolation. And we call this Alfred. I will tell you why. Because this thing, in fact, is our cornerstone for different applications when it comes to KNX bus. So this is used for exfiltration, but this is also used as a legitimate KNX device for other applications, okay? And yeah, we have this name because, of course, we went after the idea of the butler. We tried to create an acronym, but things went horribly wrong. And so we just settled for Alfred because one of our team members is a Batman fan, and that's it, okay? It's enough of an excuse. But we tried, okay? We really tried, especially the part of the ferry, because we had to ask some colleagues of ours from the electronics department for help, because this thing was hard to troubleshoot. Rewarding because we learned lots of things. It's good when you embark on such a journey. We are not experts in electronics. We know a couple of things. So we asked people who know more than us. We learned during the process. And we also created our own test bed. We have some sort of a firing range. It's a very simple test bed. So you have the rocker switches, you have a power supply, we have a KNX gateway. So it's a very simple setup, okay, that we use it to test ideas. To be fair, this is not the only environment that we use. The other two environments, the first one was an hospital, but we only play with the lightning system, okay? And the second one was the headquarters of a company that works in the construction business, and allowed us to capture traffic and create a data set. It's publicly available, by the way. And so this was to test our ideas, okay? We tried to test out of a production environment to make it sure that Alfred worked and did not break things. But then what we did was to proceed and use Alfred for our exfiltration test. So the idea was to see what we could do over the KNX bus, twisted pair, by the way. And we did an evaluation, we implemented. So this is what we could do. We must be very careful when they do this sort of thing over KNX twisted pair for a very simple reason. If you saturate the bus, people will notice, because we'll have random behaviors, like you press a switch and it takes ages for the light to turn on, or you press a switch and nothing happens. People realize and people will complain. So you should always avoid to saturate the KNX bus when you are trying to use it for exfiltration purposes. But it's feasible, okay? Even if you are willing to deal with some margin of error in terms of lost packets and so on, it's quite manageable. It's an acceptable throughput. Moreover, because most KNX setups they are not saturated in terms of bandwidth usage. Let's think about this. A line that connects, imagine, switches for lightning. Nobody is playing a game, first-person shooter, with the lightning switches. So in terms of traffic, this thing is, well, quite irregular. And I would say you have lots, a very good margin to work with to basically exfiltrate information in line over the KNX bus. So yes, it's feasible, but we try to steal a trick from the book of our Israeli colleagues to see if, imagine, okay, it's acceptable and feasible for the secure compartmented room. But most of the use cases that we have seen that, for instance, use light-based exfiltration, they assume that you have a window. Okay, you have some sort of air gapping, but it's not that important up to the point of not having a window in the office. So that's why they did the demonstration of the keyboard-led exfiltration with the drone that was filming the keyboard and so on. And we tried to understand if it was possible to do something similar with KNX. So, and we thought a little bit about it, and we discovered that most modern light fixtures, KNX controlled, have support for dimming. And those dimmers can be used for two kinds of purposes. In fact, you can buy a separate dimmer, KNX dimmer, that can do two different things. The first one is to control brightness, and they are not right now. They are designed for LED lighting, so it means that you use PWM to control brightness, and it means that these dimmers can also be used to control monophase electric motors for fans, for ceiling fans. So usually the same dimmers are sold for the two purposes. You can use them for dimming of LED lighting, but they can also be used to control the speed of a single phase motor that might be used for a ceiling fan. So our idea was like this. So imagine that I have a dimmer connected to the lights features, and I can control, let's say, brightness. Some of them go beyond this. Okay, you can control brightness, but also colors. If you have RGB LED strips, you can also control tones. And everyone who has worked with fluorescent lights knows that we have a certain degree of tolerance to flickering. We notice the flickering, but if it is within bearable limits, you can live with it. Okay, some people are more sensitive than others, but you can survive. You don't expect to see that on land lightning, but okay. So the idea was like this. What is we could modulate information using, and our proof of concept was very simple. We only worked with brightness variations, not tone variations. Probably if you included tone in the mix, it would be quite interesting. One thing that I tried to see together with our PhD student, Victor, was to try to understand if we could adjust tones within certain areas of spectrum and with certain degrees of variation that could go unnoticed to the human eye. Okay? But we were in a hurry to have a nice proof of concept to see if this thing works. So we restrained ourselves to brightness. We didn't give up on tone, okay? But for the time being, it's really brightness for us. And what we try to understand is that if it was possible to do it over KNX. And it's nice because KNX defines the idea of the group object. So each device has one of more group objects. A group object is a very simple thing. Is a memory area where you have attributes. That's it. And then you have something that basically defines a data model. They call it the data points that standardize the data models and the function blocks for ease of interoperability on KNX devices. And we discovered, for instance, for dimming, you can have two sorts of dimming controls. One of them is you have steps that are predefined, and then you can say that when I press a key, you will jump to the next step. If you press another key, you can go to the step before. But you can also use a direct value, brightness value of 8 bits that you can directly write a value that specifies which is the brightness that you want on the fixture. Moreover, the fixtures controllers, some of them, you can even define which is the real brightness for each step. If you are going step by step, for instance, on an amphitheater, you might want that something like the person presses once, and it goes like, I would say, half brightness, and then it presses twice full brightness, and then it presses again, it goes off. You can predefine on the controller which is the adequate or the level, the real level of brightness for each step. So we had everything we need. So, because on most setups you don't have BCU keys, so you can mess up with the dimmers, and you can even set up brightness levels at ease. So it means that, yes, over the KNX bus, I can have one Alfred on the place where I'm stealing information from, and I can use it instead of communicating with another Alfred. No, I'm going to directly control the device over the bus and modulate information using brightness pulses in such a way that across the street, okay, over a window, I can just film the window and get information. We implemented a very simple form of modulation. It's based on delay, so you can distinguish the bits thanks to the delay between consecutive pulses. It's called DPPM. So this is as you see, this is extremely easy to encode, but also to decode. Let's not forget, Alfred. It's a device where we had to implement the KNX stack. We don't have lots of space of real estate in the microcontroller. So even what we needed to do in terms of modulation, we pursued a rudimentary approach because we wanted to prove it was feasible or not. But this can be improved. Okay, so this is the simple modulation scheme that we used, and we did it in two different setups, 4 meters and 15 meters. And there is one thing that is not a light fixture. A real light fixture is even easier, because on a classroom with white walls, reflection amplifies the effect of the brightness variations, and it means that your region of interest, when you go to process the video, to decode, demodulate information, it's bigger and it's easier. You have less errors. So this is the worst case possible, because instead of having a widespread white reflection area that we can just catch, and it makes it more easy to just get the brightness variations and decode, we used more focused points. This was an RGB LED strip that we made very quickly, a PWM controller. We attached this to an Alfred, and we made our own dimmer. Okay, so that's the good thing about Alfred. It can be used for bad purposes, but it can also be converted on a conventional KNX device. It's a KNX device anyway. So, and we did some testing. So we modulated information, and we tried at 4 meters and at 15 meters. And what we got after doing all the cleaning, signal processing, checking for gradients, and so on, well, we got this. It's very easy once you do the proper steps to get the sequential pulses out of the video feed. And this was done using, look, my smartphone camera. Okay, so it was an iPhone S Special Edition 2020 second generation. So it was digital stabilization. I had it on top of a table for the 15 meters test, and I did lots of repetitions. Okay, but it's not a bad camera, but if I had a tripod and a really professional camera, things could even be better in terms of noise reduction and so on. So I did this with a camera that you can find on a smartphone. It was my smartphone camera, to be fair. And once you decode the signals, and this is the algorithm that we use use OpenCV, we do thresholding, we try to remove noise, use Gaussian blurring, and so on. And then this is what you see after decoding the video strip. So yes, it's possible to steal information. Okay, of course the ROI sizes need to be adjusted for your specific case. In our case, we discovered that there were specific proportions in terms of regions of interest that were more effective than others necessarily. Why? It was during the night, so you have artifacts that are induced by low light conditions, and those artifacts just affect a lot this. So in this case, you need to reduce your region of interest to have a nice balance between coverage, but getting a little bit of reflection, optical reflection from the strip. But once again, if it was a light fixture mounted on the ceiling, well, and with white walls, well, it would be way easier. Okay, so the camera setup here is really crucial. You need a good camera. I did this with a smartphone camera, but if you have a really good camera, it will be even better. Okay, especially if you know a couple of things about photography. And yeah, of course, this is a proof of concept. We got 2 bits per second. Okay, we didn't use any correct error correction codes. There's lots of room for improvement. We can mix brightness variations with tone variations. We can use a better camera. Okay, and in fact, we already did some testing, and yeah, we already got 15 bits per second, and I think we can go way beyond that. Anyway, this is enough. If you want to leak, for instance, a Bitcoin private key or an SSL certificate, it doesn't take that much to leak. It really depends on your target. Okay, so the next question is, okay, it's possible. How do you defend about this, against this? So of course, this was done within the scope of a PhD with our student Victor. So the next question was, can we defend against this? Well, in most cases, the KNX field buses and the building automation field buses are ignored. Okay, nobody. It's the old saying: if something is working properly, nobody recalls that the thing is there. Okay, it's like IT services. Do you only remind yourself that they exist when things are just broken? Okay, if things work, we even ask yourself what these guys are for, what are they are doing. Okay, so it's like for IT. And when it comes for building infrastructure security, basically nobody cares. And this is strange if you think that the twisted pair bus, in terms of physical access, it's easy to get there. It's very easy. Okay. So yeah, of course we can exclude KNX device from sensitive locations. That's something that definitely should be on the books and the recommendations. Be careful about building automation. I'm pretty sure that in lots of places they do this. It's just that it's not written on the recommendations. But I cannot believe that true professionals from the intelligence community did not think about this, to be fair. Okay. But yes, we found situations where secure compartmented facilities had KNX buses. And you can also monitor the bus. So we start thinking if it was possible to create some sort of security mechanism to deal with this. And we had a discussion internally, and we got to the conclusion that at least we should try to create some sort of network IDS for this, even if it's just to prove the point, to see what can be done, how it can be done, and what we can get out of it, and even to understand which are the problems. Some of them are not technical, as you will see. Looking at the KNX ecosystem, you should never forget that it is not about the automation bus only. You should never forget that you have people, integrators that have the ATS tool, and most likely there will be some sorts of KNX IP gateway somewhere, and probably there will be an engineering station somewhere. So if you want to protect this, look at the big picture and not focus only on the twisted pair bus, because the problem in the end might come from another place. And we had from previous projects, we had a concept that we have been working in an European project that was called PCI and that evolved in Athena, that we call it the shadow security unit. And the idea was quite nice. Imagine this: you have a programmable logic controller. So this is an automation controller, and you have something that you place in parallel with the automation controller that intercepts the communication flow with a passive tap. It means that if you lose electricity here, even if that happens, you are not going to lose connectivity. You need to be very careful in automation. You are not supposed to put things in the middle of the path that if they fail, they compromise the operation of the automation infrastructure. That's a big no-no when you work in SCADA, okay? So, and on the other side, it was connected to the physical I/O channels. And the idea was that this thing did not know anything about how this thing was programmed, but it tried to learn from the interactions with the communication side, but also with the physical control and sensing side, try to extract an abstract definition of a nominal state. What is a nominal state? What are the states in terms of normal operation? Okay, we call it this. Original was the shadow RTU because you have PLCs, but we also have remote terminal units. Are a little bit dumber, but right now the distinction has almost disappeared. But then we call it the shadow security unit. And the idea is like this: you place it in parallel with the infrastructure that you want to protect, but must be very careful that this thing, if it breaks, should never compromises either side of the automation infrastructure. And what we did when designed our network, I would say, intrusion detection system for KNX, we borrowed the fundamental ideas and architecture from the SSU. So the idea is that you have something that connects to the engineering side of things, so it connects to a conventional Ethernet network, but also connects to one or more twisted pair lines or buses, and it can also work in a distributed fashion. And it's very simple. Once again, we came to Alfred, we have it. It can be used as a device, it can be used to inject traffic, it can be also used to monitor traffic. So, and when we built Alfred, we did it in such a way that it was not a completely autonomous device. It has a serial interface, and in this case, it's the SPI, and it can connect it to, in this case, the single board computer, the SBC, it's a Raspberry Pi. Okay, so our prototype is a Raspberry Pi with an Alfred on top. So Alfred for us is like bread and butter. We use it for everything. And on the Raspberry Pi, we have this architecture that is evolved on the architecture that we had on the SSU. So here was originally the analog and digital front end. It was replaced by the bus coupling unit front end. So that is information that comes from the KNX twisted path there. So we have also first line intrusion detection system, and we will see what we did here. We also have an automated learning model, but be careful, we don't train here. We only deploy models here. We don't do training on the Raspberry Pi, just to make things clear. And then we have communication stream analysis. This is for the IP side of things. And then we have out-of-band management. We don't use the regular IP interface that is collecting engineering traffic for management. We isolate this. So we have an extra interface to have an out-of-band management interface that allows us to control this device, but in a way that is not in line with the twisted pair or Ethernet network. And then what we did, this is our prototype, by the way. So you have here Alfred on top of a Raspberry Pi. So there is that you use the native Ethernet interface for the building LAN. The bus coupling unit, the transceiver is connected to Alfred, so this cable that goes outside the picture. And then you have we added an extra USB connector, USB to Ethernet connector to have the out-of-band LAN. And to evaluate this, we devised a series of attacks that we think can be representative of the kind of things that attackers can do or can X. Like it was the case, for instance, if you look at the kill chain, okay, I would say the earlier stages of the kill chain, in cases like the one that happened in Australia. And so this is the line scan attack. It's very similar to an IP sweep. When you, for instance, take Nmap and you use a ping sweep to identify which devices are available on the range, or you more or less, this is equivalent to a ping sweep. So you go on the line, you just try several addresses to see if something responds, and you just want to identify how many devices are there and which are the addresses that are being used. So this is the line scan attack. It uses the semantics of the KNX protocol, and we attack directly the addresses, the individual addresses that are used for configuration and setup of the devices. These addresses are never used for operation of the building automation. They are only there to, I would say, configure, debug, and eventually monitor the operation of devices, but they are not involved on the daily operations of the building automation infrastructure. The other attack that it has is the device info. So if the one is the ping sweep, I would say this one is like a port scan. Okay, so the idea is that you identify a device, but you don't know what the device is. Is it a switch? It is a fixture? What is it? So I'm going to try to use the device info command to ask the device, okay, I know that you exist. what do you do? What are you? Okay, so this is direct query to devices, and there is one important thing in automation and in building automation. The interaction patterns between devices are predefined. You know, at least from the project, which devices talk with which devices. You know how the group address communication patterns are defined. So if you suddenly discover a query from a device that first it doesn't exist, that goes to another device, and that device shouldn't be getting communication attempts for devices other than the ones that were configured in the project, we have a problem. And the final one is the message injection attack, where here it's very similar to a mix of replay attacks and DOS. So you can have the slow rate attacks, and you try to poison the bus, and then you have also the flooding attack. It's similar to a denial of service by flooding. You can also try to flood the bus. If your objective is just to disable things, make it unable to work, okay, flood the bus. It's easy. You flood it, and what happens? Messages will not go through, and necessarily things will not work. You might have a good reason to do this. The context attack is interesting. On KNX, you might have, for instance, motion sensors. Imagine this, you have a motion sensor that communicates with a light fixture. What's the idea? A hall of a building. You reach the hall, your motion is detected, a command is issued to turn on the lights because you enter the building. What if the lights turn on before a motion is detected? This is an invalid context, okay? Especially if you assume that there is no manual operation of the fixture. If you don't have manual operation, and you notice that is an event, on event from the fixture that happens before the detection, it's happening here. That's what we call invalid context attack. So this was, I would say, the taxonomy of the attacks that we wanted to detect. The first thing that we implemented in our IDS was we just got inspiration from the snort rule syntax, and we create our own syntax for KNX. So that allows us to define rules, and it pretty much works like snort. Okay, it's not snort, but we thought that by using a syntax that is very well known and accepted, with some minor adjustments, would be at least sensible. Okay, why reinvent the wheel? So we created this syntax, and it allows us to create basically databases of rules that can characterize the acceptable behaviors on a KNX infrastructure. But let's be realistic. It might be feasible for a line. What about an entire building? Are you going to do this by hand? We had an idea to see if it was possible to extract this from the project. So if you have the ATS project, could we go to the project and extract the information to build the rules? Almost all the information, but not all of it. Okay, there are things that you cannot get from the ATS tool, but it could be a nice first step. But we're trying to understand, can we somehow automate this? This was our own other concern. But anyway, not only we defined the rules, but also specific attributes that are specific of KNX, okay? So they are related to aspects of the KNX protocol. So the syntax and the grammar is pretty much the same, but of course, we need to have attributes that relate to particular characteristics of the protocol and use denominations that are related to the way the protocol works, for instance, addressing. We needed to change address structures, and we need to contemplate the possibility for individual addresses and group objects. That's things that are specific of KNX. So, but yes, it was possible, and it works quite well, I have to admit. The automated learning model, we've played with simple approaches because the Raspberry Pi is not necessarily a powerhouse. So we played with, I think it was support vector machines, logistic regression, and we played a little bit with neural networks. And it's written there. And we figure out that, yes, okay, it's possible to detect even context attacks. Because let's face it, it's not an IT network. Okay, even if you might have some, I would say, asynchronous behavior, these things are like conventional automation networks, okay? You have lots of regularity here and there, and it's easy to detect nominal patterns, and it's also easy to detect deviating patterns. But in the end, okay, we got an IDS that works, and then, of course, there was the big lesson to learn. Who wants this? I have the answer for you. Nobody. Because one thing is to have a good idea that works, but we were expecting this, okay? The other thing is to be able to turn it into a product, or to see if it is feasible to turn it into a product. So the next question was, imagine that someone has designs and has a KNX network IDS. Which would be the interested customers in this sort of thing? And we talk with integrators to try to understand how the collective mindset in the market works. And we discovered something that I have to admit, it was not surprising, but it's still a lesson, I think. Most of the end users don't understand the need for this. Okay, they are not even aware of the potential problems they might get. If it is a single household, they don't care. Eventually, organizations that have a lot to lose might be interesting, but at the same time, at which price? And who maintains this? In the end, what we discovered is that it's not a hopeless case. Okay, it's not. It really depends on the way you position your offer and your value proposition. What I mean by this, it makes sense, yes, but not as a standalone product. It makes sense if you can offer this as part of the maintenance package for an integrator. That is, imagine I have an integrator that I contract because I'm building a new building, and I want for him to design the KNX infrastructure, okay? And as part of the package, he also offers a maintenance contract, imagine for 3 years. Okay, where it does engineering, debugging, troubleshooting, and deploys these just in case. That makes sense. That is, you cannot sell this directly to end users. You can even sell this as a standalone thing. But what we discovered is that integrators are willing to offer this as part of a broader service offer, like a bonus, like triple play operators do, okay, that they offer you the triple play service and this. Then if you also need or want to have surveillance, a video surveillance or one sort of security for your home, there's an extra, you pay a little bit more, and here's the same thing. It makes sense as part of the service offer. Nobody will just go run to buy one of these things. I would say few potential customers. But as part of something that is offered by integrators, it makes sense. Moreover, because the integrators understand that if things fail and they have a security incident, finger pointing will turn towards them. Yeah.
I have two
Please.
facts here. So first of all, it's not only about security incident, you could also have for malfunctioning.
Exactly.
And secondly, all these integrators, they pass through a certification scheme. So for example, there is a Instant Pass by Siemens, which I followed 10 years ago.
Yeah.
And maybe you can go direct to Siemens and tell them, I have this. Do you want to embed it in your training for the next integrators?
That's a possibility. Yeah.
And then Siemens will offer it to you. And then Siemens can also standardize the equipment that you have and make it something that can, in any case.
That's a possibility. I will tell you, they are not easy to reach.
Not only Siemens, there are other.
Yeah, ABB, for instance, they also play in this field. And I will tell you, they are not easy to reach. Okay, if you want to get this into the market quickly, the easiest way is through the integrators. Moreover, because the ones that have a big number of clients, okay, they want to automate things as much as possible, and they want to reduce the possibility of having trouble. And yes, this is also another setting point. You are absolutely right, because the mechanism that we use to detect anomalies, what distinguishes a security anomaly in certain cases of a malfunction?
The attention.
When you send someone to check. Okay, so that's it.
One big application of this is definitely in government security and homeland defense. of the applications we looked at a few years ago was that how could you air gap a room?
Okay.
So maybe a military application. So is it possible to place your phone under the light in an air gap room so there was no windows at all? And then for someone in another country to do the same, you can then create up a secure VPN connection.
Yeah.
So if you can pass the encryption key. And the problem at the time was that the cameras weren't actually that good in terms of resolution, but it looks like you managed to overcome that. So that's obviously that's a flipping your
I see.
where you can use a side channel to make sure it's like a Dropbox.
I see.
You want to make sure that only from this room to someone else's room there is a transaction. But I think certainly the application would be in government security, homeland, because they're very worried. I think it's typically spying devices in a room. So they're looking for anomalies.
Yeah, they are the natural customers for this sort of thing, I believe. Yeah, definitely. Makes sense. I didn't thought of it in that from that perspective, but it's nice. But anyway, yeah. So I've only shown you the case for KNX, but if you think about BACnet or any other automation protocols out there, pretty much the same problem. Okay, we explored this one, and there are still some loose ends to fix because we feel we can improve the needs concept. Right now is Alfred on top of Raspberry Pi. I think we can improve that, but in the end, the curious thing about this is it's not easy to sell. I'm not saying it's not impossible. It means that you need to think about how to position this from a value perspective. That's different, but that's a challenge anyway. And what I shared with you was what we learned from talking with integrators, that they told us, oh, you will never be able to sell this as a standalone thing, but maybe as part of a service offer, so that's something that you also add for peace of mind, might be interesting. Okay, and this is the current state of affairs regarding this project. By the way, Victor is going to defend his PhD on the 12th of June. So, but I think he managed to do it. And there is another thing that I'm going to tell you about Alfred. Alfred is being used in production, but you don't know for what. We have a friend that has an apartment that he rents. He rents the rooms, but he doesn't want to deal with the having to open doors and deliver keys and so on. So they created a system that uses SMS. So the customer, when he books a room, okay, when he does the check-in, receives a code, and he can use the smartphone to automate unlocking of the doors and access the room and so on. And all of this was done with Alfred. Okay, because Alfred is also a conventional KNX device. We use it to implement this. So it's an automated system for an apartment where a friend of ours is renting rooms. Okay, and Alfred is being used in production. So the same thing that we use to steal information is also helping people to enter in their own rooms. So yeah, regarding that, at least we got a product that is so flexible that it can be even used for this. And that's it. That's the end of my presentation. If you have any questions, please.
Thank you.
Thank you.
So how many Alfreds do you have?
4, 5, eventually. We are not that good with the soldering iron. And SMD is sometimes is tough to solder. Well, you can pre-order.
Have you imagined of creating something that is more integrated, so small? Have you discussed with any company that you can actually create something that you can plug?
Not at this stage.
It doesn't look like it.
Not at this stage, to be fair. Moreover, because there are other. This is not an easy market, okay? Because right now, if you want to do proper building automation, you are going definitely towards KNX or something like DALI. DALI is more for lightning, and you have gateways between DALI and KNX, whatever. But end users, conventional people, they don't care about this. They buy a couple of Shellys, from an electronic store, and they do it by themselves.
Yeah, because they're still a bit expensive. That's
Yeah.
So they try to put some smartness in their houses.
Yeah. Yeah, and
We've also got Apple and Google trying to get into this market, but I think Apple and moving out high.
Yeah,
I'm just focusing on one or two devices.
I know. Yeah, I have that impression. They opened the platform a little bit for third parties, but their specific offer is quite limited. Yeah.
Okay. So do you have any questions? Yeah. From online, I can see online something.
It was death by PowerPoint. They are asleep.
See, it's a global statement that construction industry is an industry. Cybersecurity is a company who are integrating with the university, and it surprised me that the number one thing that's keeping them awake at night is cybersecurity.
Yeah, but
so I think we think maybe of a home market, and nobody's going to buy this for a home, but I think for intelligent buildings, and to be able to manage a real estate, because you would feed this into a security operations center, I would think. So it's part of your edge of your corporate environment. So I definitely think there is a big market for it.
Yeah, you are right. There is another problem. It's problem of scale. In Portugal, let's face it, integrators are not that big. But of course, I also believe the natural progression for this is that you not only provide the device, but you also outsource, that is, the customer outsources to you the SOC service. So the idea is that the integrator could eventually, if it is a medium-sized integrator, I don't envision that you will need a big integrator for this. It could have a SOC for several customers, okay, and have this service. Yes, and makes all sense. In Portugal, the ecosystem is small, but
But it's like ransomware. It's the ultimate weapon against someone. A denial service against a big building, a hotel, Trump Tower.
It already happened.
Something like that. That could be attacked.
I think the Google headquarters in Australia also they were attacked, and it was through building automation. So this is a serious thing. Okay, it's not only for exfiltration. You can basically create serious issues. Hotels are big customers for this sort of technology. Lots of KNX deployments out there are in hotels. Now imagine smart locks.
Yes, that's what I was thinking. This is something that we could discuss with companies.
Yeah, but I think smart locks are going to be Ethernet and IP-based.
Some of them are, I won't say, but in several places they are KNX. And you have to pair there.
But also KNX, it looks like IP. They have similar addresses.
And you have KNX over IP. That is also being used for field buses in some cases. The idea is that, okay, twisted pair is kind of expensive because it means that you are deploying twisted pair just for building automations. And some integrators start thinking, I put UTP cable everywhere and I run KNX on top of it. And that's it.